Hello, my name is Andrew Berkowitz, and this is my lab report for Physics 2022 Lab 3 at Georgia Tech, which is measuring magnetic field from a magnetic dipole. The main purpose of this lab was to explore and understand the Earth's magnetic field and magnetic fields of bar magnets and magnetic dipoles through a hands-on experiment. By using a bar magnet and a magnetometer on our phone, we observe the relationship between distance and the strength of a magnetic field, and we use the Biot-Savart law for magnetic fields to find the dipole moment of our bar magnet. A few physics fundamentals that were used in this lab included using a bar magnet to model a magnetic dipole, the Biot-Savart law, which gives us the magnetic field for a bar magnet dipole, and the distance dependence formula of a bar magnet. A few assumptions used in this lab included that the net magnetic field in our system is the result of the Earth's magnetic field and the magnetic field of the bar magnet without any outside interference. Another assumption is that the magnetometer app on our phone is an accurate form of measurement and that the bar magnet can be modeled by a magnetic dipole. The results of our experiment are a value for the magnetic dipole moment of 2.08 amperes times meter squared and a value of n of negative 2.98. Now for the experiment itself. The system of this experiment was the bar magnet and Earth, while the initial conditions were the bar magnet and the magnetometer. The details of the experiment were that we start by pinpointing the location of the magnetometer on the phone by sliding the phone vertical and horizontal perpendicular to the ruler. Next, we place the bar magnet at different distances perpendicular to the magnetometer and then measured the net magnetic field as a result. We then linearized this model as shown on the right. Lastly, for this experiment, we found the off-axis magnetic field of the bar magnet by moving the magnetometer to an area that was neither parallel nor perpendicular to the bar magnet. As shown on the bottom, you can see the magnetic field and components of the magnetic field given and averaged. Next, we used our experimental data to find a value for the moment of the magnetic dipole. Starting with the distance-dependent equation that we got from our experiment, we have the value of y equals negative 2.98x minus 14.53. Then we inserted these values from this equation into the equation ln b of x equals ln k plus n ln r. Finally, we set the distance-dependent equation equal to the magnetic field equation, inserting these values for the distance-dependent equation, and we ended up with a value of the magnetic dipole moment of 2.08 amperes times meter squared. Shown here is excerpts from my GlowScript code. On the left side, we can see the insertion of our magnetic dipole moment, which we obtained from our calculations. And you can see a function that I defined to give us the magnetic field at a certain distance from that magnetic dipole. On the right side, we can see the creation of 6 points from which we measured the magnetic field. 2 of these points will be on axis and the other 4 will be parallel to the magnetic dipole. Shown on this slide is the GlowScript model generated by my code and the value of magnetic field at each of the 6 observation locations. Finally, for the final results of this experiment, so the value recorded from the experimental value of the off-axis magnetic field was 4.95 times 10 to the negative 5 teslas, while the value obtained from our GlowScript code was 1.87 times 10 to the negative 5 teslas. So the experimental value was 2.65 times greater, which shows there was some discrepancy in our experiment. Some possible sources of error include that the phone app and magnetometer may not have yielded accurate results, and we may have had errors in initially finding the point on the phone where the chip is or in accurately calibrating for the Earth's magnetic field. Finally, for the discussion of this experiment, starting with question 1, if we had not oriented our experiment to compensate for magnetic north and had laid the meter stick out at some intermediate angle, we would have had much less accurate measurements. We would have had to factor the Earth's magnetic field out in each measurement, which could have created further discrepancies between the experimental and theoretical value. Finally, the last question, if we were to stick two identical magnets together and run the experiment again, the experiment would run essentially the same as to how it ran here. However, we would just simply see double the strength of the magnetic field because we could superpose the magnetic fields of the two magnets.